Hi everyone, I'm Mr. Joseph. I'm a chemistry teacher, and today I'll be teaching on the mole concept. A mole is the standard unit of amount. It is what contains the Avogadro's number of particles. One mole of any substance contains the Avogadro's number of particles, and this particle can be an atom, it can be a molecule, it can be an ion. One mole of an element contains the Avogadro's number of particles, which is what 6.02 times 10 raised to power 23 atoms. If it's an element, if it's a compound, a molecule, it will be 6.02 times 10 raised to power 23 what? Molecules. If it's an ion, it will still be 6.02 times 10 raised to power 23 watts. So 1 mole of any substance, be it an element or a compound, contains the Avogadro's number of particles. One mole of sodium as an element will contain 6.02 times 10 raised to power 23 atoms of sodium. And also which is equal to what? The relative atomic mass of sodium, which is equal to what? 23 grams of sodium, which is the relative atomic mass. That means 1 mole of sodium contain what? 23 grams of sodium, which is equivalent to the relative atomic mass of sodium as an element. But if it's a compound, let's say 1 mole of carbon dioxide, CO2, contains 6.02 times 10 raised to the power 23 molecules of sodium, of carbon dioxide, I mean to say. That means it's also equal to the relative molecular mass of what? Carbon dioxide, which is equal to what? 44 grams of what? Carbon dioxide. What that means is that 1 mole of a molecule, 1 mole of a compound, is equal to the relative molecular mass of that particular compound. Therefore, we say number of mole is equal to mass over molar mass of the compound, or number of mole is equal to mass over relative atomic mass of the elements. So with this, n is the amount, which is the number of mole. We can calculate the mass, we can calculate the molar mass. To calculate the mass, m will be equal to number of mole times the molar mass. Molar mass will be equal to what? Mass over divided by the number of mole. So it's just for us to make each variable the subject of the formula if you have to calculate what? The number of moles. So we'll be looking at different problems today based on A levels. So the mass of 1 mole of a compound is the molar mass of that compound. The mass of 1 mole of a compound is the molar mass of that compound. If it's a covalent compound, we say it's the relative molecular mass. If it's an ionic compound, we say it is the relative formular mass, which is the mass of 1 mole of that compound. Now let's look at example. Let's look at some examples. Example 1. Now this is an example. Strontium metal can be extracted from strontium oxide by reduction with aluminium. One of the possible reactions is shown. What is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium oxide using this reaction? The first thing we need to look at is to ensure that the equation is balanced. What that means is that the number of atoms of any element on the reactant must be equal to the number of atoms of any element on the product. After that is done, from what we've seen, you can see that the equation is balanced because on the reactant we have 6 atoms of strontium. On the product we also have 6 atoms of strontium. On the reactant we have 6 atoms of oxygen. On the product we have the same 6 atoms of oxygen. On the reactant we have 2 atoms of aluminium. On the product we have 2 atoms of aluminium. So the equation is balanced. That is the first step. That's the first thing to look at. Now you are asked to calculate the maximum mass of strontium metal that can be produced from the reduction of 100 grams of strontium oxide using this reaction. So what that means is that we are dealing with strontium oxide and strontium metal. So for you to solve this calculation very fast, you need to concentrate on the reactant that is specified and the product that is specified. So they say, what is the maximum mass of strontium metal that can be produced from the reduction of strontium oxide? So we're dealing with strontium oxide and strontium metal. So on the reactant, that means 6 moles of strontium oxide reacts to form what? 3 moles of what? Strontium. So we look at the mass of 6 moles of strontium oxide. Strontium is the relative atomic mass of strontium is 88. So it will be 6 brackets 6 brackets, it's 8 plus 16, which is the relative atomic mass of oxygen, reacts to give 3 brackets, it's 8 with the relative atomic mass of strontium. So if you multiply this, you have 624 grams of strontium oxide reacts to give you, if you multiply 3 by 88, you get 264 grams of what? Strontium. So from the balance equation, 624 grams of strontium oxide reacts to give you what? 264 grams of strontium. Then I ask, what is the maximum mass of strontium metal that can be produced from 100 grams of strontium oxide? So what you do, simple proportion. So if 624 grams of strontium oxide reacts to give you 264 grams of strontium, then 100 grams of strontium oxide will react to give you what mass of strontium. So what you have to do here, you cross multiply. You now have x will be equal to 100 multiplied by 264 gram divided by 624 gram. So x, now I'm going to use my calculator. So what I have to do now is 100 times 264 divided by 624. So the answer will be 42.3 gram. Therefore, the answer to this question is B, which is 42 gram. Thank you very much for listening. I advise you to solve as many questions as possible. And if you have any question, feel free to contact me and I'll always be there for you. Thank you very much. Have a nice day.